Hello everyone and welcome to this my video on gradient and direct proportion, part of the year 9 course here in Australia, but probably the year 10 or the year 8 course throughout the rest of the world, so it is really valuable to watch. Now if you don't already know, my name's Darren from Maths Guru. Yes, Maths Guru, my little corner of the interweb where you can sort of go over there, sign up, get free downloads, exam questions, these notes, videos. My goodness, could I be any more caring? Well, yes I could, but what I need is something from you if possible. Can you do me a favour and subscribe to my YouTube channel? By the end of the day, when I get 3 extra subscribers, to tell you that I'm running around my house like a complete lunatic going, yes, 3 more people that aren't my mother, it actually means the world to me. So often I want to give up creating these videos, but people say to me they're useful, and hopefully you'll do me the honour of just subscribing. It really does mean the world for me. Now, what I would normally do is go ahead and explain all of the stuff here. It's building on the stuff we've done in previous videos, again, on mathsguru.com. But it's now going to build it into using words that try and trick you. Proportionality, for example. So should we get started? Now, when we look at this, we've looked at straight lines and more recently what the idea of gradient means. And if we remember, gradient is basically, do we use G? No, we don't, because G stands for gravity in maths. How confusing. Thank you, Barry. The gradient is given by the rise divided by the run. So if I'm at a particular point on my graph, if I can count how many squares I go across and how many squares I then go up to get to another point on that line, then I can actually work out the gradient. That's a measure of slope or slopiness or whatever humor I used in my previous video. But actually, straight lines mean something a lot more important. And we can describe them as being basically directly proportional. You're going to say, what do you mean directly proportional? Well, just it's language. Come on, guys, you should know this now by now. Yeah, this is very much a straight line. And what we notice is if I was to choose a point on this line, and let's say that point there, and go across 1 and go up 1, it's going to get me to another point on the line. Now, if that happens every single time where I go across 1 and up 1 and get to another point, across 1 and up 1 to get to another point, then we can say that that line is proportional, directly proportional, whatever, yes? Now, it doesn't have to be 1 across and 1 across, as I say all the time. I could go 2 across and 2 up, so long as, starting at my new point there, I go 2 across and 2 up to get to my next point on the line, it is proportional. Now, these lines can start anywhere, yes, but something that's going to become more important later on in the course is knowing where this point here is, or what this point here is, yes? And we call it our y-axis intercept, and it actually has meaning in lots of real-world situations. Again, we won't get into that. Now, something else, language-wise, you need to know is something called the rate of change, right? So that is, by how much does my y value change in comparison to my x value, right? So if I go 1 across, my y value changes on 1. So actually, that's a, hold on a moment, that's a gradient. Barry, you've at it again. You're so freaking annoying, mate. Yes, but actually yes. So what I'm going to tell you now is actually the rate of change is exactly the same as the gradient. But again, we'll come back to that in just a moment, because if we're looking at how many squares across we go and how many up we go, ka-ching, life is good. So that's pretty much what we're going to look at today. Now, let's make it a little bit more formal. Let's talk about rate of change. The textbook, and thank you very much, Cambridge, for allowing me to use your examples, basically talks about rate of change being a change in y values divided by a change in x values. So again, that says if we choose a particular point on the graph and we draw a triangle, we're trying to see, well, how many y does change, or how many units of the y-axis do we cover in comparison with how many of the x-axis. If in this situation we went 1 across and 1 up. But again, we've said that that is also equal to our gradient. And yes, here is another way for our writing our gradient formula. y2 minus y1 over x2 minus x1. It's just saying, when we've got a point, take the y value here and subtract it from that y value there, because that's the 1 square we went up. And if we want our x2 minus x1, it's take the x value we got to away from the x value we started at, right? And these are all gradients. So rate of change, gradient, means exactly the same thing. So let's have a look at something that's really important to us, like average speed.